Okay, guys, we are going to finish up 1.6, Part A. This is a special way to answer polynomial factoring questions when our polynomials don't look like what we usually have them look like. And I'm going to show you a reason why we have to do these substitution problems this way. And it's so we make sure that we get all of our answers, because sometimes the imaginary ones can be hidden. So when you come out to a problem like this is probably something that you guys have not seen before, right? We have fractional exponents. What we notice about this problem is that the first two terms have the same base. They have the same thing in common. They're both x plus 1. If you notice, this exponent is to the 2/3 power. This exponent is to the 1/3 power. And we could also say that this could have the base of x plus 1 to the 0/3 power, which would just cancel out and just become 1. So when you have this case where the first two have the exact same thing, but their exponents are fractionals like 2/3, 1/3, we can use something called substitution. So the first thing I'm going to do is I'm going to say what I'm going to let a letter equal. We'll use u. It's called u substitution. So I'm going to say, okay, I'm going to let u equal x plus 1 to the 1/3 power. Always set it equal to whatever the middle term is. So then I can look at this as a factoring question. I can say like this would be u squared minus just u minus 2 equals 0. See, this is our squared. This is to the first power, and that's to my 0 power, which would give me just the number 2. And now we can just factor like normal. So what are the factors of -2? That'll multiply to give me -2, add to give me -1. That's going to be u minus 2 and u plus 1 equals 0. And now we're going to solve. How do we solve? Well, what we said u was equal to, we're now going to plug in to our factored equation. So I have two new equations that I'm going to write. I'm going to replace u with x plus 1 to the 1/3 power minus 2 equals 0. Now I'm going to replace this u, with x plus 1 to the 1/3 power plus 1 equals 0. And we're going to solve. Okay, so let's get, we can get everything to one side. If you want to rewrite this, first of all, if I have something to the 1/3 power, that's the same as the cube root. So I can write this as cube root of x plus 1. If I move this 2 to the other side, I'm going to add 2. So this becomes equals 2. So how do you undo cubing something, the cube root? You're going to cube. So what you do to one side, you do to the other. So we're going to cube both sides. So I have x plus 1 equals 2 cubed is 8. Then I'm going to subtract 1 from both sides, and x equals 7. Same thing over here. I'm going to rewrite this as the cube root of x plus 1. If I move this 1 over, this becomes -1 over here. How do you get rid of cube root? Well, we're going to cube both sides. So x plus 1 equals -1 times -1 times -1 is -1. I'm going to subtract 1 from both sides, and I get x equals -2. So your two solutions are x equals 7 and x equals -2. And it's a really easy process. I know it appears like, what? This is crazy. I've never seen this before. And that's okay. We're going to work through a couple here, and then I have a couple extra that I want to show you at the end, just to make sure that we're on the same page. We're understanding that these are all just factoring problems. So I look at number 12, and I say, okay, so I have 3 terms. Kind of looks like a quadratic function. I have 2x minus 1 and 2x minus 1. This is to the 2/3 power. This is to the 1/3 power. Remember, we can say that this is to the 0/3 or 0 power. So I'm going to use substitution to help me make this problem a little easier. I'm going to say, let u equal whatever that middle term is. So 2x minus 1 to the 1/3 power. Now I'm going to replace my 2x minus 1 to the 1/3 power with my u's. So this is going to become u squared plus 2u minus 3 equals 0. Now this is a much more manageable problem for us to look at. What are the factors of -3? That are going to multiply to give me a -3, but add to give me 2. So the u plus 3, u minus 1 equals 0. And now we're going to take what we said u equaled, and we're going to plug it back in to each factored piece and solve. So I have 2x minus 1 to the 1/3 power plus 3 equals 0. 2x minus 1 to the 1/3 power minus 1 equals 0. Simplify a little bit more here. This is going to become the cube root of 2x minus 1. If I move this 3 over, it becomes negative 3. How do you get rid of the cube root? Well, you're going to cube. What you do to one side, you do to the other. So 2x minus 1 equals negative 27. I'm going to add 1 to both sides. 2x equals negative 26. Divide by 2, and x equals negative 13. Same thing over here. I'm going to rewrite this as the cube root of 2x minus 1. When I move this negative 1 over, it becomes positive. So now we're going to cube both sides. And when we cube both sides, we get 2x minus 1 equals 1 times 1 times 1, which is 1. We're going to add 1 to both sides. So 2x equals 2. Then divide both sides by 2, and x equals 1. Good job. All right, looking at this next one, I think this one's actually easier. It looks a little like, oh no, we have a fraction stuff, but this looks like our normal kind of factoring problem where we have squared, first power, and 0 power. We don't have to worry about fractionals. But right away, guys, I see I have an x over x plus 1 squared, and then I have an x over x plus 1. So what we're going to do here is we're going to say, okay, I'm going to let u equal this x over x plus 1. Always, whatever this middle term is, we're going to set u to. So now this becomes a lot easier for us to deal with. We're going to say 6, instead of my rational, I'm going to say u squared plus 5u minus 6 equals 0. So let's see if we can factor this. Factors of 6 times negative 6 is negative 36. That's going to multiply to give me negative 36. So that would be u plus 9, u minus 4. Again, guys, your a term is not 1, it's 6. So we need to divide both of these by 6. So that leaves me with u plus 3 over 2 and u minus 2 over 3. Both of these are set equal to 0. So when I rewrite these parentheses, this becomes 2u plus 3 times 3u minus 2 equals 0. And now I'm going to take what I substituted u for, and I'm going to plug it in here, and I'm going to plug it in here and just solve. So I have 2 times x over x plus 1 plus 3 over 1 equals 0. And then over here I have 3 times x over x plus 1 minus 2 over 1 equals 0. Okay, let's solve the left-hand side. 2 times x is 2x over x plus 1. Well, if I want to add these two together, I need a common denominator. So my common denominator would be x plus 1. So what you do to the bottom, you do to the top. So this leaves me with 3x plus 3 over x plus 1 equals 0 over, we could say x plus 1. So now that my denominators are the same, we can get rid of them. So combine like terms. 2x plus 3x is 5x plus 3 equals 0. So I'm going to move this 3 over here. So I have 5x equals negative 3. And then I divide both sides by 5, and I get x equals negative 3/5. Now, what we need to be careful of, guys, is we have to make sure that my denominator does not become 0. So if I plug in negative 3/5 up here, is that going to give me, if I add negative 3/5 to 1 right here, is this going to give me a 0? No. If I plug it in here and squared, is it going to give me 0? No. So we're good to go. One of your answers is x equals negative 3/5. Same thing over here. We're going to solve. So I have 3x over x plus 1 minus, well, what do I need to do? If I need a common denominator of x plus 1, I'm going to need to multiply the top here by x plus 1. So minus 2 times x plus 1, and then equals 0. So now that we all have the same denominator, we can get rid of it. So 3x minus 2x minus 2 equals 0. Combine these two here. I have x minus 2 equals 0. Add 2 to both sides, and x equals 2. Okay, last one we're going to look at here. And you guys are like, oh my gosh, you just keep throwing crazy stuff at us. Well, let's think about this. If I have 6x, all right, I can write this as 6x. And then I could say minus, I can rewrite the square root of x as x to the 1/2 power minus 3 equals 0. So if we wanted all of our exponents to have a common exponent or common denominator, do you guys agree with me that this 6 to the first, I could rewrite this as 6 to the 2/2 power? So then I have 1/2, and then this would be to the 0/2. So I'm going to go ahead and say, okay, that makes sense. This looks like our first couple factoring problems that we did. I'm going to replace with the middle term here. So I'm going to let u equal x to the 1/2 power. So when I replace that here, I'm going to have 6u squared minus 7u minus 3 equals 0. So now we're going to multiply. See if we can factor this. Negative 18. What are the factors of negative 18? That multiply to give me negative 18, but add to give me a negative 7. That's going to be minus 9 and plus 2. Since my a term is not 1, I have to divide both of these by 6. So this is going to give me 2u minus 3 when we simplify. 3u plus 1 when we simplify. And then I'm going to take this and plug it in here and here and solve. So I have 2x to the 1/2 minus 3 equals 0. I have 2x to the 1/2 plus 1 equals 0. Well, how do we write 1/2 as instead of a fractional exponent? This is 2 times the square root of x minus 3 equals 0. So let's isolate our x. I'm going to add 3 to both sides. This becomes 2 times x equals 3. Divide both sides by 2. I get the square root of x equals 3/2. And now how do you undo the square root? You're going to square both sides. So when we square both sides, I get x equals, this goes to the numerator and the denominator, so I have 9/4. I see here, look, I went from a 3 to a 2. Oh, silly me. So let me rewrite this. This is 3x to the 1/2 plus 1 equals 0. So I have 3 times the square root of x plus 1 equals 0. Remove this 1 over. 3 times the square root of x equals negative 1. Divide both sides by 3. And I get the square root of x equals negative 1/3. How do you undo the square root? Or we're going to square both sides. So this becomes x equals 1/9. Now, what do we have to be careful for? Well, in the last problem, we had to be careful. We had to check to make sure that my denominator did not become 0. In a case where a square root is involved or something like that, we have to make sure that the solutions that we actually find are true. Let's just take a second and check. So I'm going to take 9/4, plug it back into the original, and see what happens. So we have 6 times 9/4 minus 7 times the square root of 9/4 minus 3, and see if that does equal 0. So when I simplify, this will become a 2, and this becomes a 3. So 3 times 9 is 27/2, okay? If I take the square root of 9, I get 3, and the square root of 4, I get 2. So this gives me minus 21/2 minus 3. Does it equal 0? Well, 27 minus 21 is 6. 6/2 minus 3. 3 minus 3 equals 0. This works. So good. X equals 9/4. We're good to go. So let's check 1/9. Same thing. I have 6 times 1/9 minus 7 times the square root of 1/9 minus 3. Does that equal 0? So we'll simplify here. This becomes a 2. This becomes a 3. So I have 2/3 minus, this becomes 1. This becomes 3. So 7 times 1 is 7/3 minus, I'm going to go ahead and change 3 into 3/3. I'm sorry, 3/1, which would become 9/3. So 2 minus 7 is negative 5 over 3 minus 9 over 3. Gives me negative 14 over 3 equals 0. Is that a true statement? No. That means this, x equals 1/9, is not a valid answer. So in this case, we did all that work and we found out that x equals 9 over 4 is our answer. All right, go to the next slide. Don't just stop and say, oh, okay, we already did this. I'm good to go. I have some problems that we need to work on. And I want to bring this to your attention because I'm not sure where we hit this in our notes, but I'm sure it's coming up and I know it's going to be on the test. Now, some of you look at a problem like this and you say, oh, I'm just going to add 81 to both sides. And I get x to the 4th equals 81. I take the 4th root. And I say, what number times itself? 4 times gives me 81. I get plus minus 3. It's a even root, so we have to say plus or minus. And I cautioned you guys about this the other day because it's very important. You have to fully factor. You just can't go through and just, oh, I'm just going to move stuff from one side to the other and just solve. You have to fully factor because in all of these problems that we're now going to encounter, we're going to have some hidden solutions in here. Because when I just solved it that way, I got 2 answers. I got plus minus 3. But how many answers should I come up with? You actually should have 4 in this case. So you always need to factor first. I'm going to say what times what is going to give me x to the 4th? Well, it's x squared. What times what's going to give me a negative 81? 9 and 9. So when I write this out, I have x squared plus 9 and x squared minus 9. Set equal to 0. I can factor this a little more. This becomes x minus 3, x plus 3. I cannot factor this anymore, so this just stays as x squared plus 9. So now that we've fully factored, we're going to set equal to 0. So I say x squared plus 9 equals 0. I move this 9 over. I get x squared equals negative 9. How do you undo the square root? Undo the square, you take the square root. So x equals, guys, there's a negative underneath here. So I have plus minus 3, and that negative is the value I. Over here, when I solve, I have plus or minus 3. So notice I have 2 answers here and 2 here. If you just moved 81 over and took the 4th root, you would miss those 2 imaginaries. So you've got to make sure you fully factor. In a case like this, I notice, well, x cubed and 27 are both perfect cubes. So if I go ahead and factor this, I know my a term is x. I know my b term is 3, right? X cubed, this would be 3, and this would be x. And then we have left here x squared minus a times b, so 3x plus b squared, which is 9, equals 0. So now we see, we're going to set this equal to 0. So x plus 3 equals 0, x equals negative 3. There's one of our answers. And now we see if we can factor. Are there factors of 9 that are going to multiply to give us 9 but add to give us negative 3? No, so we'll have to use the quadratics. So we have negative b plus or minus the square root of b squared, which is 3 squared minus 4 times 1 times 9, all over 2 times 1. So simplify that a little bit. We have 3 plus minus. 3 squared is 9 minus 36 divided by 2. Simplify a little more. Come over here. So I have 3 plus minus the square root negative 27 all over 2. So then I'm going to say 3 plus minus the square root of 27. I'm going to break that down as 9 times 3 times negative 1 over 2. So when we pull out a perfect square, the square root of 9 is 3. The square root of negative 1 is I. So this leaves me with 3 plus minus 3i root 3 over 2. Those are my 2 other x values. If you guys notice, 2 imaginary solutions, 1 real, but I knew at the beginning I had a total of 3. So same exact thing here. This is the perfect cube pattern, but it's not the difference. We're adding. So what times what is going to give me x cubed? That's going to be x. What times what is going to give me 512, and that's positive 8. So my pattern looks like this. X plus 8. And then I have a squared, which is x squared, pull minus a times b, so 8x, plus b squared, which is 64, equals 0. So here, when I set this equal to 0, x plus 8 equals 0, I get a solution of x equals negative 8, which is great. That's real. And then my second set, I'm going to say, okay, it's not going to factor, because there's no factors of 64 that'll multiply to give me negative 8. So since my b term here is even and my a term is positive, I'm going to go ahead and do completing the square. And I am going to, hold on one sec, move 64 over, so it's negative 64, then I have my square over here. So take my b term, which is negative 8, divided by 2, I get negative 4. So my parenthesis here is x minus 4 squared equals, well, when I square negative 4 here, I add 64 on one side. What you do to one side, you do to the other. So we get negative 48. So now if we continue solving, we're going to take the square root of both sides. When you take the square root of both sides, remember, you have to have your plus or minus. And then I see I have the square root of 48. So I'm going to break that down into 48 times negative 1. Don't forget about that negative, guys. So we have x minus 4 equals plus minus. I'm going to break 48 to 16 times 3, and then our negative 1. So when I take out my perfect squares, I have x minus 4 equals plus minus. This is going to be 4i times the square root of 3. And then the last thing I'm going to do is add 4 to both sides. So this is 4 plus minus 4i square root of 3. And those are my other two answers. They just both happen to be imaginary. And lastly, we're going to look at number 4. All right, looking at this last problem, make sure you take this squared off on the third term. It should just be x to the fourth minus x cubed plus x minus 1. So let's talk about factoring. If I want to create something that is factorable, let's see what we can take out here. If I take out an x cubed here, I am left with x minus 1. So what can I take out of x minus 1 that will leave me with x minus 1? Well, I could just take out a positive 1, and then I'm left with x minus 1. So our GCF here is x minus 1, and then my leftovers are x cubed plus 1. So if you notice here, guys, we have x minus 1 set equal to 0. X is going to give me positive 1 as a real solution. And then I have the difference, or sum and difference of cubes again. So this is going to give me x plus 1. Then I'm going to square my a term, so x squared. I'm going to multiply a times b, so I get minus x. And then I'm going to square my b term, so I get plus 1 equals 0. So I end up now with another parenthesis I can set equal to 0. So x plus 1 equals 0, x equals negative 1. And then I come over here and I say, okay, can I factor? Are there factors of positive 1 that'll multiply to give me positive 1, add to give me negative 1? No, so I have to use the quadratic. So negative 1 plus minus negative 1 squared minus 4 times 1 all over 2 times 1. And let's just simplify. 1 plus minus 1 minus 4 over 2. This gives me 1 plus minus the square root of negative 3 over 2. And then I see that negative underneath. That's going to be an I that comes out. So 1 plus minus I root 3 over 2. So there are my 4 solutions. I have positive 1, negative 1, and plus minus 1 plus minus I root 3 over 2. So make sure, guys, when you have these problems that say fully factored, there's going to be imaginary solutions hidden inside. So we've got to make sure that we fully factor.